Aha! Right, we've got projectiles, and this is question number 1. So here we are, we've got a particle B. It is projected from point O on horizontal ground with a speed of 28 meters per second at an angle of elevation of 30 degrees. The particle moves freely under gravity after projection, and then we've got to find 3 things. We've got to find the greatest height reached above the plane, the time of flight, which is how long it's in the air for until it hits the ground, and then the range of the projectile is how far it travels horizontally, again before it hits the ground. So those 3 things, have a quick go, and we'll catch up in a couple of seconds to go through the answers. Righto, it is solution time, so let's get going. Now, to begin with, you should always make a sketch. So we'll sketch out what's actually happening. So we've got this particle here. It's being projected at a speed of 28 meters per second at an angle of 30 degrees. Now, where do we start? With all of these, you want to resolve this to find a vertical initial velocity. So I'm going to put that as uy, because that's the initial velocity but in the y direction. And then we also want to do the same in the horizontal direction, so I'll put that as ux. So if you don't know how to resolve, make sure you check out this video here on resolving. That will give you a few little shortcuts there to how to resolve. Now, to resolve this to the vertical, this would be 28 sine 30, and then in the x direction that would be 28 cos 30. So what we've done there is basically said that this 28 meters per second, well, this much of it, 28 sine 30, is acting upwards in the vertical direction, and 28 cos 30 of it is acting in the horizontal direction. Okay, perfect. And now we're ready. So we'll make a very quick sketch of the path of this. It's going to go upwards, and then eventually it's going to turn and fall back into the ground at some point. And now what we're looking for in part A is the greatest height. Now the greatest height from our diagram is here. But what's happening at the greatest height? Well, think about it. This particle is moving upwards, so it's got some velocity going upwards, but then it's going to stop and come back downwards. So what we need to realize is at this point here, its vertical velocity is equal to 0. Now, vertical velocity, we can say that Vy is going to equal 0 at that point. And what are we looking for? We're looking for its greatest height, which is that there, and that's going to be s, its displacement in the y direction. So what we should do now is just set up a few key bits of info. So vertical, and now what we're going to put down is s in the y direction, u in the y direction, v in the y direction, a in the y direction, and t. So I've just put Subat out there, and what we're going to do is start filling out the info that we have. Now, I'm going to take everything going upwards to be positive. Okay, so that's really important. You must decide what's positive so you know what signs to use. Now, if we're taking upwards as positive, then we know that this y, so u in the y direction, is going to be positive. So I'm going to put that as 28 sine 30. We know that v of y, so it's vertical velocity, is going to equal 0. So I'll put that there as 0. Acceleration, we know gravity pulls things downwards, so that's acting in the opposite direction. So we need to put a negative 9.8 over there. And we're looking for its vertical displacement, so vertical s, so question mark over there. Do we need t? No, so we'll just get rid of it. So now if you highlight the info we've got s, u, v, and a. So what equation has those things? That would be v squared equals u squared plus 2as. And now we're looking for s, so we need to rearrange this very slightly. So that'd be v squared minus u squared equals 2as, v squared minus u squared over 2a, and that's what equals s. Now let's plug in the info. So we'll have 0 squared take away 28 sine 30 all squared, and then divide that by 2, lots of minus 9.8. There we go. That's going to give us s. So punch that all into the calculator real quickly, and I think that actually comes out bang on 10 meters. So what we just found out there is actually the greatest height it reaches is 10 meters above the ground, or 10 meters above the plane. So let's put that there, 10 meters. Awesome. Right, the next thing we need to do is find the time of flight. Now, what is time of flight? Well, how long it's in the air for before it smashes into the ground. Now, it smashes into the ground over there. So what we want to do is find the time at that point. How do you find the time at this point? Well, what do we know? If it hits the ground, then its vertical displacement, so s in the y direction, is equal to 0 because it's back on the ground. So what we'll do is maybe set up another one of these suvats, but just change the value slightly because of what we need to find. So let's do this again. I'm going to put vertical over here, just clear a little bit of space, and then let's put s of y again, u of y, v of y, a of y, and then t. Okay, so we know s of y is 0 because it hit the ground. Initially, the velocity was still 28 sine 30 in the y direction. V of y, do we know the speed when it hits the ground? Not really, so I'm just going to put x there for now because I don't really know it. Acceleration, well, again, I've taken everything up as v positive, so acceleration we'll put as minus 9.8, and we're looking for t, time of flight, so we'll put question mark over here. So now looking at that, what have we got? We've got s, u, v, no, we don't have v, what am I talking about? We've got s, u, a, and t, there we go. So s, u, a, and t, that is going to be s equals a ut plus a half at squared. There it is. Let's plug in some numbers. So 0 equals 28 sine 30 lots of t plus a half times by minus 9.8. No. Yes, minus 9.8. And then t squared. So that's going to be just t squared. Okay, cool. Let's simplify this a little bit. 0 equals 28 sine 30t. Half of 9.8 minus 4.9 t squared. There we go. Okay, now to solve this, what should we do? I think we can just factorize. So just pull out t from there, and we're left with 28 sine 30. Take away 4.9 t. There we go. Okay, great. So outside here, we can say, well, t is equal to 0. But inside here, we're going to say t is going to be, that would be 28 sine 30. Over 4.9. So we need to punch that one into the calculator. Let's do that real quick. 28 sine 30 all divided by 4.9. That comes out as, we'll go to three significant figures. That's be 2.86. Yeah, 2.86. There we go. Seconds. Okay, we're happy with that. So what we're saying is that it crashes into the ground over here after 2.86 seconds. Perfect. And the last part then, what do we need to do? We need to find the range of the projectile. So that's how far it's gone horizontally before it whacks into the ground. So let's clear out a little bit more space just over here. There we go. Okay. Now when it crashes into the ground, we already worked out the time when it crashed into the ground. We know it's after 2.86 seconds. So now we need to start to fill out a suvat. But because we're looking for the range, which is horizontally, we need to look at everything in the horizontal direction. So we need s, x, u, x, v, x, a of x, and then t. Now, we're looking for sx, so how far it's gone in the horizontal direction. So I put question mark there. U of x, we already worked that out. That was 28 cos 30. V of x, I mean, I don't know the speed when it gets there, so I'm just going to leave that. Acceleration. Now, gravity only acts in the vertical plane, and so acceleration here is going to be 0. And do we know the time? We do. It was 2.86, which is what we worked out over there. But maybe use the whole decimal, right? Which was like 2.85 something, something, something. So make sure, do use that when you're doing this calculation. And now what do we have? Let's quickly highlight this. We've got S, U, A, and T again. Okay, so we need the same formula. S equals UT plus a half AT squared. So S equals, that's UT, so 28 cos 30 times by T. And then because A is 0, well, all of this is going to cancel out because it's going to be a half times 0 times time squared. So we don't even need to fill that out really. So all we've got to do is punch this in. That's going to be 28 cos 30 times by 2.86. So what does that equal? Let's do that real quickly. So that would be that times by 28 cos 30. And that comes out as, we'll go 3 sig fig, 69.3 meters. And there it is. Okay, so nice easy projectile question done. So a few key things to remember. Make sure you do a diagram. The next thing is going to be resolve that initial speed there into vertical and horizontal components, right? So ux, and uy. Make sure you get that, and then you're ready to start the question from there. So, nice question done. There's more coming, so make sure you stay tuned, and I'll catch you in one of those real soon.